Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, welcome to the 23rd lecture on the SwayamPrabha course titled Maritime Structures, offered by Department of Maritime Engineering at IIT Gandhinagar. In this lecture number 23, we will learn more about the loads which are acting on maritime structures, though there is a separate course which deals with computing these loads and the effects of these loads on maritime structures with mathematical equations and design examples. In this lecture, we will discuss very briefly about the introduction to these kinds of special loads in addition to the conventional loads which will act on maritime structures, which will follow this lecture. So, welcome to lecture 23, fire, explosion and blast loads. So, we will talk about only the primitive idea about the difference between these three kinds of loads, how are they effectively causing damage to maritime structures, and then how do they grow, they steady state remain and they decay, and what is the time frame likelihood, how are they modeled. We will look all these aspects very briefly in the primitive level as just a level of understanding of this particular topic in this course. Of course, there is a separate course available to understand this in much more in detail in terms of design perspectives as well under SwayamPrabha. Okay? So, let us talk about fire, explosion and blast loads. Before understanding the loads caused by fire, let us understand fire and the related combustion process. Friends, what you see in the screen now in enlarged view is a fire triangle. Classically, fire triangle has got three arms. One is called as a fuel arm, other is called the source of heat, and a third one is the oxygen supply arm. Friends, in any situation, be it maritime industry or any other situation, if all these three arms are present, then only there will be fire. On the other hand, if any one of these arms is absent, fire cannot take place. So, let us apply this concept of understanding to maritime industry. Let us talk about an offshore platform or a coastal structure or a processing plant which is located offshore or on the coastline. So, we know being an open source of environment, oxygen is available in abundance. Okay? And being a processing plant or an offshore or drilling plant or an LNG storage platform or a processing unit, fuel is anyway present in abundance, right. So, if by accident, if you have any exposed source of heat coming in contact with the fuel, the platform or the asset will catch fire immediately. Okay. So, the three arms are essentially required for fire to happen. So, fire is a rapid oxidation process of the material where an exothermic chemical action takes place. Exothermic refers to heat being radiated out when the combustion takes place. So, fire is a rapid oxidation process. Okay, it is a very fast process where exothermic chemical action takes place, which is a combination of combustion, releasing heat, light, and of course, certain reaction products as a result of this combustion. Fire is a visible effect of this combustion. Okay. A special type of chemical reaction is fire. It occurs between oxygen in air and some sort of fuel combination. These fuels can be solid, liquid or gases. The reaction will be keep on continuing to happen as long as there is enough heat, fuel and oxygen present in the scenario. We call these three presence arm as fire triangle. So, essentially the balance of heat equation looks like this. If fuel is added to fire, oxygen, and in the presence it releases carbon dioxide and hydration, and of course, it also exothermically emit heat. Now, let us talk about offshore processing or exploration platforms where we deal with hydrocarbons. Hydrocarbon is a combination of carbon and hydrogen. For example, methane CH4. So, hydrocarbon is a combination of carbon and hydrogen. Hydrocarbon essentially are fuels which are compounds of carbon and hydrogen. Methane is a very simple composition of this. The most unfortunate and undesirable characteristic of hydrocarbon fire is that the temperature this fire can reach is as high as 1200 degrees Celsius. Okay. It is about closer to the melting point of steel. So, 1200 degrees Celsius is rather a very high temperature where hydrocarbon fire is capable of reaching this temperature. Conventional fire accidents which happens in houses or industries etc., will reach maximum about 300 to 400 degrees Celsius, very rarely about 600 degree. Okay. Beyond that it will get extinguished. Hydrocarbon fire grows to a temperature rise up to 1200 which is more dangerous. Therefore, controlling or extinguishing hydrocarbon fire needs special arrangements and firefighting systems. Before we understand the design for fire, shortly we will talk about classification of fire. Fire is like material, fire is also classified. We can classify them as A, B, C, D, K fires. A refers to fire involving organic solids like paper, wood, they are a class A fire. If we involve fire with flammable liquids and gases, they are B and C fires. If we involve this with burning metals, we call them as class D fire. If the fire takes place in the presence of grease oil or oil fires, then we call them as class K fire. So, fire classified is A, B, C, D and K. In addition, we also have something called electric fires, okay, which is outburst of failure or short circuit of electrical equipments. Friends, see the devastating image of a building, Quebec, Canada, where the structural fire has reached from the bottom till the top of the roof, and whole structure is getting completely attacked and influenced by fire. Okay? So, the fire can cause devastating effects in the surrounding as well as degradation of material very seriously. So, the course is also co-lectured by Professor Gaurav, who is also the Chief Executive Officer of the Fire Engineering Laboratory at IIT Gandhinagar, will give you more idea and more detailed information about structural design for fire in different course contents. However, we are just trying to explain you basically how fire is classified. Now, one may ask a question, why do I know about classification of fire? If you do not understand the classification of fire, you cannot plan appropriate extinguishers for fire, because all extinguishers cannot be applied to control all class of fire. For example, you cannot use water for electric fire and so on. So, if you do not know the classification of fire, planning or preparing for extinguishing fire is rather difficult. Okay? So, according to DNV code of practice, fire is again classified in a different form: no fire risk, low fire, medium and high fire risk. So, fire classification in DNV code is not based on the material which is burning, it is based on the risk caused by fire. If I say no fire risk, then these are buildings which has no energy resources. If I say high fire risk, these are buildings or assets which store flammable liquid and high power electric machinery. For example, offshore structures, maritime structures meant for oil and gas exploration, production, processing, storage, LNG all fall under this category. Okay? So, offshore topside in general falls under this category. So, fire can be classified in two different ways: based on the material which is burning, based on the risk the fire causes on the buildings or structures or assets. Having understood this, let us say if a structure is exposed to fire load, what happens to the structure? Let us look at this industrial network of pipelines, etc. When the fire outbreaks, the most important element which follows fire is the smoke. Okay? Smoke covers a wider area than fire, which prevents the visibility of source of fire and also obstructs the firefighting process very seriously. Sometimes these contents of the flame and smoke are non-inhalable, therefore, they can also cause fainting of people and blindness partially to those people or the firefighters who are surrounded by the smoke or dense fog. So, heavy industrial structures, process industries, nuclear reactors, offshore and maritime structures, chemical processing plants are all susceptible to fire loads. Apart from conventional buildings, we also have electrical fire accidents, friends. So, when a thick smoke or a dense smoke forms when the fire is initiated, we call this as flash fire of vapor. Okay, it is like a vapor because white in color, but it is a flash fire. So, we will talk about what is a flash fire slightly later in other slides in this course. So, how do you classify, how to compute the fire load? To compute the fire load, let us first understand how the fire propagates. Okay? So, there are two ways by which we can look at it. One is what we call as a natural fire curve, the other one is what we understand is standard fire curve. Okay? Fire curve is actually indicating the propagation, the growth rate of fire on a scale of time with temperature. So, therefore, this is also called as TT curve. Okay? Time temperature curve. Okay? Time temperature curve is also called as TT curve. So, let us look at this curve carefully. Let us look at the blue line which is showing the natural fire curve. The natural fire curve starts at 0 time and 0 temperature. As the fuel and oxygen is completely fed in, the fire grows. It comes to a stage where it reaches a certain temperature. We call this stage as ignition stage and this stage as the fire growth stage. Okay? So, at this point the fire is almost fully grown, right. Then if at all we want to extinguish fire, it should be within this region. Once the fire is later grown and burning stage, it is very difficult to control fire for two reasons. One, look at the temperature. The temperature from here to here is approximately double of this. So, there is a very steep rise in temperature when the fire starts burning. Okay? When the fire starts growing, it is not in a rapid stage, but of course, it is on an accelerated mode, but one can think of controlling extinguishing fire at this stage. Beyond this stage, it is very difficult to extinguish fire, except that it will result in devastating damages. So, if you look at the standard fire curve, the fire curve gets initiated, what we call ignition stage, it further grows, we call growth stage. This is the temperature at which one can think about extinguishing fire. Till this temperature, one can. Therefore, if you have any firefighting equipment, any fire service engines, all should be invoked to control them before this temperature or before this time. So, TT curve will give you both the ideas, right. Okay. Once the fire starts burning, it grows rapidly and temperature is reached to the peak. Once the temperature reaches its peak, then it declines. So, this is called the backbone of the curve, where the declining part, where the decay part of the curve is included in the natural fire curve, whereas the standard fire curve taken for design of structures under fire does not start from the 0 stage. It starts from the growth stage onwards and it rises, and it is a point where the natural fire curve and standard fire curve intersects. So, the temperature at which you need to control fire remains same, or the time remains same, whether you are using the standard fire curve or natural fire curve for your analysis. It does not matter. Okay? But however, friends, the standard fire curve gets the maximum temperature only after larger time beyond burning. Okay? So, there is no backbone of this curve at all, it keeps on continuing as long as the fuel exists. So, there can be fuel control fire or ventilation control fire. You can either control ventilation or you can control fuel supply to extinguish fire, okay, or to fight fire. So, the standard fire curve does not have a backbone decay, whereas the natural fire curve has a backbone decay. However, the temperature raised or reached by a natural fire curve is much higher than at the corresponding point at the standard fire curve. Okay? The standard fire curve is what we take for design of structures, whereas natural fire curve is a real curve which is used for programming the flammability controlled firefighting systems. The standard fire curve is used to establish the fire rating of material. Every material has got a fire rating. So, the equation is given here, which has the certain temperature and the equation empirical. So, let us now compare the Eurocode curve with ISO fire curve. The red one what you see in the screen is the ISO fire curve, whereas the blue one is the Eurocode fire curve used for structural design. So, the comparison of these fire curves as you see in this literature is again TT time temperature curve. One can see very well here that the Eurocode model takes the fire up to a temperature about 1100 degrees Celsius. Okay? Whereas the ISO curve, the highest temperature is about 1200, but after 300 minutes. Whereas in Eurocurve, the fire is instantaneous to 1100 degrees Celsius within about 10 minutes. Okay, that is a classical and fundamental difference between using Eurocode for fire resistant design or using ISO curve for fire resistant design. Okay. These are different phases of combustion what you see as the fire starts initiating. The fire initiation only the source gets the fire, whereas in the growth stage the surface gets fire heated. When the sustained burning stage, the surface around gets fire. Okay. It is the maximum possible surface under fire which is in the growth stage or sustained burning stage. It is in this stage firefighting becomes very difficult. So, firefighting should be positively and effectively done before it reaches the burning stage, okay, in terms of time or in terms of temperature. So, in the burning stage you get circumferential burning all around the building. Okay. In the decay phase, of course, the intensity reduces, and at the end of combustion the fire gets back to the source which is controlled. These are the different phases of combustion generally in an accident of fire. So, then comes to a question, how do you estimate fire as a load? Like we know dead load, live load, imposed load, impact load, wave load, wind load, ice load, earthquake load, current load. How do we get fire load? The total amount of available energy which is released during fire is the fire load. So, fire load essentially is quantified in terms of energy. This is characterized by something called FLED, fire load energy density, expressed in so many joules per square meter. Okay. So, fire load is expressed as fire load energy density, and it depends on two parameters. One is the amount of combustible material available, the second one is the geometry of the room, not only the size but also the shape and location of the openings. In a given room, the ventilation size, ventilation opening all need to be located and looked into to compute FLED. Let us quickly look at some examples of FLED. The fire load of a room can be computed as sum of product of Mi and Ci, where Mi is called the mass of the combustible item in kg present inside a room, and the calorific value of combustible item is given as Ci. For example, if I have a room Let us say I have a room, this is the flooring of the room, okay. I have a door here, okay. We have a window here, okay, and we have another door here. So, let us say there are some items, let us say a table, there is a chair, and there is a big item present here, there can be a side table present here and so on, and these items are let us say made of wood. Let us also imagine that we have a curtain for the door as well as the Venetian blinds for the window. Okay. The Venetian blind for the window, this is the curtain for the door, these are wood furniture. So, each item has a mass and each item also has a calorific value. So, what I am saying is compute each one of them in terms of mass, because Mi is given as so many kg, we know the mass, and Ci it depends on joules per kg or megajoules per kg. So, there is a standard table which is available for all kinds of material which is used in general construction practice. If you do not have those special materials used in industrial practices, one can also conduct experiments to estimate the mass and calorific value of each of those materials or composites in fire engineering laboratory. Professor Gaurav will explain you a simple example how this can be done and calculated in the later part, but however, for every material we know the mass and we know the calorific value. So, if we sum them up, I get something called fire load. Okay. So, then if I know the fire load in terms of megajoules, can always find the fire load energy density, which I divide this fire load by the area, where A is the area of the floor in square meters. In some codes of practice, you will also add the total internal surface area. For example, it generally used to be only the area of the floor, only this area, okay. Only this area is to be used in the denominator, that is here. Sometimes you will also add the total internal area, this plus this wall, the ceiling and the wall. So, you add all the internal area together and compute this. Okay. So, however, for the fire load estimated depending upon the mass and the calorific value of the combustible material present there, one will get total E. If we divide the total E by the area of our understanding, we get something called small e, which is called fire load energy density expressed in megajoules per square meter. If I know that, can always compute something called the heat release rate, which is HRR, one of the important input for fire resistant design. So, how do you compute that? It is expressed in watts or joules per second, which is given as Q, which is this value of E what you computed divided by time. Okay, that is called heat release rate. You can also work out something called heat release rate per unit area, which is called flux. So, that is nothing but the small e divided by time. So, if the capital E by time is called HRR, if you do small e by time, it is called flux, okay, heat flux. So, friends, these are 4 important terminologies which we repeatedly use in fire resistant design of structures. So, one can compute them. Okay. Once you compute them, then let us see how do we model fire, because that is important to do software analysis. So, a typical model which has been shown here, you can see there is a drop object which is hanging from the ceiling, and these are the ventilators. This is the roof and the walls and the floor. Okay. There is a combustible source which is generating heat or fire. When the fire is actually modeled, the fire spreads in the plan and in elevation like this. So, this can be modeled, and we will also teach you how to model this using software in another course of fire resistant design in detail. However, for this, if I know how to model the fire, then we must first calculate the fire load characteristics. There are different approaches to make this model. One is using empirical equations, the other one is using Swedish fire curves, the third one is a solid frame model, and the fourth one is of course the complicated CFD model. Okay. CFD applications are also available to model fire. Some of the applications are FDS, Fire Dynamic Simulator, PyroSim, Flax, and Chameleon FireX. These are all different software, commercial software available in the market to model fire. If I know the basic properties of fire, I can use these models which are developed based on detailed computational fluid dynamics. Now, the question comes, if I know how to compute the fire load, how to model fire, for believe me, we know how to model or how to handle the software, etc. Then let us talk about how to handle fire. Fire has occurred in the maritime industry, how to handle fire. So, how to prevent fire, how to suppress fire. Okay. Fire prevention can be essentially done using something called flammability diagram. So, flammability diagram will help you to compute the amount of oxygen fuel mixture which is used to control fire. Okay. So, you have to make this mixture out of something called flammable range. If this mixture reaches out the flammable range, fire can be prevented. Okay. So, therefore, regular maintenance and inspection of equipments, pipelines and vessels to prevent the leaks are very important to prevent fire. Furthermore, proper firefighting training is to be given to personnel who handle this kind of situation to avoid potential hazards and to also implement safe practices against firefighting. When we talk about fire suppression, there are FSS, what we call fire suppression systems, which are installed in maritime structures and offshore structures and heavy industrial structures to suppress fire. Some of them are sprinklers, foam systems, water deluge systems, which are used essentially for pool fires. One can also use fire resistant coatings on structural components to delay the temperature rise during fire. So, the fire resistant coatings do not extinguish or control fire, they only delay the time to reach the maximum temperature, so that you can delay this process of fire growth and hence firefighting can be made effective. Okay. Now, let us come to what is firefighting. We already saw the three arms of a fire triangle, which we said heat, source, fuel and oxygen. There is a fourth arm added to this, which is called the chain of reaction of this. So, together this is called fire tetrahedron. Fire can be extinguished or firefighting can be done in the following ways. One, can cool the temperature by adding water. We can also do something called smothering. Smothering is limiting oxygen exposure on the fired surface by pumping in carbon dioxide or any inert gas. Starving is limiting the fuel supply to the potential source of fire. Interrupting is inhibiting the chemical chain reaction by applying extinguishing media to the fire. Some of the examples could be dry powder, BCF and other halon extinguishers. So, friends, offshore platforms and maritime structures commonly use fire deluge and sprinklers. Let us also quickly see some of the fire protection systems which are commonly used in maritime industry. Something called flame arrestor, which is a passive device which prevents propagation of flame through pipelines. In some places, people also use fire barriers and foams or fire insulators and sprinklers or spark preventers to control or protect structures from fire. Sometimes you have commonly seen people use fire extinguishers, either powder based, foam based or water based. So, the powder based extinguishers are what you see, which is commonly seen in most of the buildings. There is fire extinguisher powder based, and this is a very rare extinguisher which is water based. So, you will see nowadays under the firefighting practices implemented in almost all industrial practices in India as well as in abroad, you would see the fire extinguishers placed at distinct locations in all buildings almost, which will help us to extinguish fire. So, there are other industrial protection systems available to protect fire. One of them is a wet chemical fire suppression system, which is used in large industrial kitchens. Okay. The schematic layout looks like this. If you are having a large cooking base, okay, then there is a control panel wherein the pipe and fittings are all and the extinguishers are fixed here. So, the containers are usually stainless steel containers. Okay. So, we have pneumatic heat sensing tubes which are passed through these extinguishers, which are kept exactly above the fire source, which is power supplied. The control panel which controls the flow through this pneumatic heat sensing tubes. So, these tubes has got heat sensors located different locations. The heat sensors will break open the valves when there is a heat or fire released. So, through this fire extinguishers are operating, they will control fire. Okay. So, there are discharge nozzles which help you to open up the valves and control fire. The second type of system is a dry chemical fire suppression system used again in large industry. The most of the working principle is common with that of the existing one, except that in this case dry chemical suppression is being used in firefighting, whereas here wet suppression is being used. Okay. The third one is a clean agent of existing system, which is a common practice which is used in storage areas like LNG containers. In fact, oil tankers, people use this kind of extinguishers, which is clean agent fire extinguishing system. The last one is a polymer tube based automated pre-engineering system, which is used for a controlled volume, very small space. Okay. Having understood some introduction to fire, growth of fire, fire load estimates, softwares used for modeling fire and fire detection, suppression and control systems, we will now move on to explosion. Explosion is a sudden release of energy, often caused by blasting of vessels which are pressurized or flammable. Explosions are various types: VCE, vapor cloud explosion, which results from ignition of vapor cloud formed by leakage of flammable material. Pressure vessel explosion, the name itself is very clear, it is caused by overpressure within a vessel and the vessel bursts out. Boiling liquid expanding vapor explosion, BLEVE, is a very common accident of fire or explosion which happens in storage chemical plants, which is very common in hydrocarbon industries in maritime structure. It occurs when a sealed vessel containing pressurized liquid like CNG, etc., is exposed to external heat and it blasts. So, when it does, the boiling liquid expands into vapor and causes explosion. So, we call this as Blavy explosion. The other type of explosion is condensed phase explosion, which is CPE, which involves either solid or liquid explosive material, often seen in organic and inorganic compounds. Friends, even dust can explode. Okay, fine dust like wood industries can also explode. So, dust explosion is resulting from combustion of fine particles suspended in air and common in grain silos and coal mines. Now, to understand the explosion effects, we will talk about the flammable vapor concentration versus temperature. So, the explosion characteristics are divided broadly into two: the upper flammable and lower flammable limit of every chemical or mixture. Okay. If the chemical reaches its flash point, okay, then onwards the lower flammable limit decreases with increase in temperature, whereas the upper flammable limit increases with increase in temperature, expanding this volume to receive more source for explosion. Okay. So, once you have an explosion happens, the blast waves propagate. The blast wave typically reaches its maximum, what we call peak overpressure, then decays and causes a suction effect and then dies. Okay. From the atmospheric pressure, it takes some time, what we call arrival time, to reach its peak. Okay. Once reaches its peak, it degrades or decays, but does not stop here. It expands to become a negative pressure and then comes to normal. This is the most dangerous part in terms of damage caused to structures. Apart from this, of course, this is also dangerous, but this is most dangerous. So, peak overpressure is the maximum pressure an explosion or mixture can reach. Impulse is the integration of overpressure with time. Now, when I want to find out the effect of this explosion on structures, we do this indirectly computing scaled distance. The scaled distance is given by this equation, where the function of the distance of the explosion from the source, which is exposed in R, and then equivalent mass of TNT. So, whatever may be the mixture available at site, you compute the equivalent mass of that mixture in TNT. So, there are chemical handbooks available which will give you the equivalent mass of TNT for any chemical admixture. For example, the book authored by me on HSC practices, published by Wiley, helps you to find out the TNT mass of every chemical admixture. So, if I know the TNT mass, if you know the source of explosion from the point of interest for my calculation, can compute something called scaled distance. Once I know the scaled distance, I will be able to compute the effect of that explosion based on this scaled distance using empirical equations. We are not discussing about the procedure here, we are only saying how an explosion is actually modeled and how it can have an influence on the overall firefighting structural design of maritime structures. If fire and explosion happens, what are the hazards and consequences? It creates thermal radiation which can emit high levels heat and capable of causing very severe burns to human. It can also initiate shock waves where overpressure can be developed, leading to structural damage and human injuries. It can also cause fragmentation where the vessel fragments will divide into pieces to project and adding to further destruction. Furthermore, friends, explosion and fire can also release toxic gases, especially in confined spaces. These gases can become very harmful to human because they contain carbon monoxide and leading to asphyxiation. If we look at the fire and explosion characteristics, There are a few terminologies which we must learn to understand. Combustion is a chemical reaction. Ignition is a result of combustion. Auto ignition temperature is the lowest temperature at which the flammable chemical will ignite by itself in the absence of any source of heat. That is very important. Okay? Spontaneous combustion occurs due to increase in temperature caused by exothermic reaction and initiates self heating of the material. Flash point is the point of a volatile chemical and is the lowest temperature at which it gives off enough vapor to form an ignitional material. Fire point is the lowest temperature at which the vapor above liquid will continue to burn once ignited. Upper and lower flammable limits are respectively the highest and lowest concentration in percentage of gas or vapor in air, which will define the flammable limits of an existing combustion mixture. Limiting oxygen concentration is the minimum oxygen required, below which combustion is not possible. So, as I said in the firearm or the fuel triangle, you need fuel, oxygen and heat source. You need minimum oxygen to set fire. So, if you are able to avoid that minimum concentration of oxygen in any situation, you can always extinguish or prevent fire accidents. So, prevention and control therefore comes from looking at the flammability diagrams. Flammability diagram is anyway not a part of this lecture, but I would urge you to go through this particular book on HSC authored by me, and this book helps you how to draw a flammability diagram for different kinds of hydrocarbon fire. So, you can use flammability diagram as a designer to depict the safe range within which I can extinguish fire. You can also provide the proper spacing and ventilation in a given room to prevent vapor cloud formation. One can also install fire suppression systems like foam for pool fire and sprinklers for general protection, which you will nowadays see in almost all public buildings. Sprinklers and foams are anyway installed in all public buildings. One can also carry out regular inspection and maintenance of pressurized vessels and pipelines to avoid leakage, which can also cause devastating fire. If at all an explosion happens, how to control them? There are three ways to control or mitigate explosion. One is explosion mitigation, emergency response and monitoring systems. In maritime structures, monitoring systems and emergency response are mandatory by design. Okay? They are compulsory by design. Okay? So, by incorporating pressure relief devices, pressure relief valves, etc., one can mitigate explosion. You can also design structures to sustain explosion. You can also plan layouts to minimize congestion during explosion. One has to also use personal protective equipments, what we call PPEs, to plan for emergency rescue during fire accidents. One can also install gas detectors, flame detectors and pressure sensors in a layout of maritime industry to monitor systems. Therefore, they can give sufficient warning in advance to outburst of fire in case of accidents. There are example cases where we can have pool fires, jet fires and levee in maritime industry or in process plants. Pool fires are common in oil storage areas. Jet fires arise from pipeline leaks and cause very distinct damages in given structural system. Levee of course contains or is an outburst of vessels with fireballs and overpressure. So, one can also mitigate the blast wave effects by structural design, by spacing and layout and by protective measures as we discussed in the previous slide. So, friends, let us come to the summary of this lecture. This lecture helps us to understand fire, blast and explosion characteristics. They are expressed and explained in the primitive manner just to understand their influence on maritime industry. Of course, we have also seen some practical cases where firefighting can be controlled, mitigated, or how to adjust the flammability limits of a given system, how to use sprinklers and foams, etc., how to use detectors to have early warning systems in maritime industry. Friends, of course, this lecture has got a lot of parallel references on HSC book and firefighting design or fire resistant design book, which are authored by me, which are available in the reference list of SwayamPrabha course website. Please see them, have additional reading to learn more about them. Thank you very much. Namaste.